Uh, Hello everyone. Today I am going to explain what is Cloud Run on Google Cloud Platform and how can you use it. So Cloud Run is basically a service which is built on top of Kubernetes, but you don't see the details of Kubernetes or hard parts of it. So you can create services on the Cloud Run and expose them to the public internet or for your other applications in the same virtual private network. So in order to run Cloud Run, you don't need any pricing or billing information on your account. But in order to use containers in your container servers, you need billing enabled. So I did it beforehand. So it actually uses Google Storage Engine, which is free up to 5 gigabytes per month. So you can just enable it and use freely. Also, before the meeting, I deployed 2 applications. Now I will show how to create and deploy a simple application. There is actually a demo application already present in the Cloud Run to get you started. You can say test app here, and we want everyone to access this API from the website. It actually gives you the URL for your applications to see. So there's demo containers. Let's deploy demo one first. Yeah, it deploys the application in seconds. Let's see. It deployed, and you get this URL over here. So when you click it, see, it's deployed. Only thing about Cloud Run is it's only for HTTP applications. It handles this certificate stuff automatically, so you don't have to deal with this stuff. You can just use normal HTTP applications. It will provision the certificate for you. So also we can create new version of this application and do blue-green deployment. As you can see here, this gets now 100% of the traffic. I have also uploaded another application beforehand. So yeah, actually the container. So we just select the image from our registry. Let's say version 1 of this app, and my port is 8000. You can, you can select other stuff like variables, how much memory to allocate to this container. Can say variables, and you can add SQL connection. Because these containers are ephemeral, which means that there is no actual disk in the container, so they are always getting removed and moved from one to another, and you don't know how many containers actually running the application. So because I selected, let me show you again. Because I selected this checkbox here, it instantly deployed new version of the app here, revisions, 100% traffic. So let's click here, and now you see the timestamp. This application just prints the timestamp every time you use it. So let's say we may want to do little less percentage for this application because there might be a critical change. So I want to deploy the second version of my app. The port is the same, but I don't click this. So let's see, everything is correct. First, it starts the container here, but it doesn't give the traffic to that container. So the load balancing part is entirely handled by Google. You don't do anything for the networking part. You just say how much traffic you want to give it. Let's say new one, I want it 50%. So it provisions the load balancer in the background. Let's see. Okay, when I refresh this page, it says hello world, and it changes according to which part it drops to. It depends actually on the load balancer. So there is no session cookie here, so it always gives to another instance. Let's see. I want to do it 100%. I am sure now it is correct. So when I do that, it gets 100% of the traffic. So we won't see. Sorry, this one 100%. We won't see timestamp anymore. So go here. Yeah, every time it gets the hello world part. So for the URL part, it gives you this kind of URL, but you may not want to use this. So you can actually manage custom domain. You just need to verify domain beforehand, and you can just say add mapping. Let's say test app. I have this domains here. Test.dortgentere. So I already have DNS records recorded here, which may take time because of the DNS. So I just give the star. Yeah, okay. But this takes time because this actually gets the certificate from the authority. So you get the green thing like here, secure connection. So it provisions the certificate from Let's Encrypt. It's taking a little bit time. So let's get to some actual usage. I created a WordPress here. For that, you need Cloud SQL. You can create instance here, MySQL 5.7, which is also provisioned by Google. So you don't need to do SQL setup. You can even add users from the panel. Yeah, it's coming. Yeah, I added WordPress user, create the account, and there's demo one database. So let's create demo 2. Yeah, okay, great. Okay, it's getting created. Now I will deploy new version because currently there is a website. Here I created before this meeting. Now I will change the domain, the MySQL schema, so I can create new website from scratch. And again, it deploys here. You can also see the logs from the containers, what it gives as an output. Let's see, more sensible one. Let's say test app here. Logs. And here you can see I entered with Chrome and other stuff. Yeah, this is production environment Flask application. So let's refresh this page. Okay, it might have failed. I don't know. Revisions. New version. Okay. 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 Let's remove this. And yeah, I break it. Okay. Demo. So yeah, you create it from scratch. Let's say test site. Let's copy this and admin. your website like this. And you can actually create many websites like WordPress without paying any price. So because of the streaming, I have a little bit slower connection. Let's see the logs of the WordPress. Yeah, I closed the connections. Test. You can actually see the website right now, wordpress.com.tr. And you say visit website. This is it. And that is all actually. Thank you for listening. Okay. Is anyone having any questions? Okay.
Can you see my screen? Okay, welcome to iyzico Lightning Talks. My name is Yalçın and I'm the head of software engineering at iyzico. I'm looking forward to talking with you today about domain-driven design. Let's get started. First of all, did you know that poor quality software costs organizations $2.8 trillion in the United States alone? And this is roughly 10% of the country's GDP. To decrease that cost, we need better design systems. My goal today is to help you understand the core concepts of domain-driven design to make better system designs. First, I'm going to present the definition. Domain-driven design is a set of design best practices for complex, especially complex domains, to build a domain model in a right way. It's also a systematic approach to software design process, and it provides a common language for development and business teams. Specific topics covered include domain modeling and preferring rich models rather than anemic models, and splitting responsibility layers and bringing large-scale layers with bounded context. Second, let's look at the domain models. A domain model is an object model of the domain that incorporates both behavior and data. Also, it creates a web of interconnected objects where each object represents some meaningful individual. I mean, it can be whether as large as corporation or as small as a single line. On the right, you can see that contract and product objects, they have behaviors or methods, and they contain data, which is also persisted to database as an example. The next thing I will share with you is an anti-pattern, which is called Anemic Model. The basic symptom of an anemic domain model is that it looks like the real thing, real model. There are objects, many named after the nouns in the domain space, and these objects have rich relationships between each other and structure. They have the structure that true domain models have. But when you look at the behavior, you realize that there is any behavior on these objects, which makes them little more than bags of getters and setters. Indeed, these models come with the design patterns that say you that you are not put any domain logic in the domain objects. Instead, there are a set of service objects which capture all the domain logic, carrying out all the computation and updating the model objects with the results. These services usually live on top of the domain model and use the domain model for data. But this is a procedural style design, not a real object-oriented design. In an anemic domain model, services contain business rules. Therefore, service objects have relationship with service objects, and data access objects are the same. But in domain-driven design, models contain business rules and data. Service classes don't contain business rules in the domain-driven design. Instead, they provide application layer, like, for example, a RESTful API for domain objects. For example, here a sprint class has many backlog items. A sprint has many backlog items, and they have a structure that true domain models have. But when you look at the behavior, you can see that there is any behavior on these objects. These objects are the models which contain only data or fields. Instead, there is a sprint service object carrying out all the computation and the business logic. Service class actually updates the sprint and backlog model objects with the results. Here is a better alternative called rich model. Rich models have both business rules and data. On the left, you can see that sprint class has some fields as data and a validation logic as behavior. On the right, backlog item class has also fields and a method or behavior named commit to sprint. So you can commit a backlog item to a sprint with a backlog item class. Here I will show you the different layers used in domain-driven design. The first one is application layer. Application layer, it defines the jobs the software is supposed to do and directs the domain objects to work out problems. The layer is kept thin. It does not contain business rules or knowledge, but it coordinates tasks and delegates work to domain objects in the next layer down. It doesn't have state reflecting the business situation. The second and the most important layer is domain layer. Domain layer is responsible for representing concepts of the business, like information about the business situation or business rules. The business situation is controlled and used here, even though the technical details of storing it, for example, bursting it to database or bursting it to a cache, they are delegated to the infrastructure layer. And domain layer is the heart of business software, and you should delegate all the infrastructure complexity to infrastructure layer. Common mistake is not fitting the behavior into an appropriate object and putting the behavior in application layer. Additionally, let's look at the two terms used in domain-driven design: bounded context and ubiquitous language. Bounded context is one of the most important concepts of DDD. We can say that it is a conceptual limit where a domain model is applicable. That means any use of that vocabulary outside of that limit will probably mean something different. We can say then that a bounded context is mainly linguistic delimitation. It is really important to understand that each bounded context will have its own language. For you to develop an efficient ubiquitous language, you need to understand the business. One of the great advantages of this language is to bring together the domain experts and the technical team and the others involved in the project. The language must always be spoken between the team members and expressed in the software model. For example, sales context is a bounded context in the domain and has its own terms, its own language. Sales and engineering teams should speak the common language. So a software engineer should name the entities via this language. Context maps is also a topic of domain-driven design. Context maps show the relationships between the different bounded contexts. There are several ways to relate bounded contexts. First one is shared kernel. Shared kernel is a shared context between two or more teams, which reduces the application of code. However, any changes must be combined and notified between teams. Customer supplier is a different relationship. It's a relationship between client and server. The other name is downstream and upstream. Between client and server, where the two teams are in continuous integration. Conformist is the scenario that involves the upstream and downstream teams. But in this model, the upstream team is not motivated or is not required to meet the needs of the downstream team. Partner is the scenario where teams are dependent and need to have a cooperative relationship so that they can meet the development needs of both systems. And finally, anti-corruption layer is the scenario that the client creates an intermediate layer that communicates with the upstream context to meet its own domain model. Like, for example, API gateways can be an example for that. But it doesn't require to be an API gateway. You have an abstraction layer that decouples client and server. It's an anti-corruption layer. In conclusion, if you would like to understand more about the main topics covered by domain-driven design, DDD learning map is essential for this understanding, as well as being a great guide to learning planning. You can easily find it from Google by searching DDD learning map, and you can look at the most important topics and learn them. Finally, here are the references that I used to prepare this presentation. Thank you.
Hello guys. I'm gonna start with my presentation. I hope you can hear me. I'm gonna share my screen. Can you see my screen now? Okay, great. Hello guys again. My name is Mohammed. I'm a front-end software engineer at iyzico. Thanks for being here with us. Today I'm gonna talk about server-side and client-side rendering in web browsers. Let me start first with mentioning just a minute. Yeah, let me start first with mentioning what does the render word means in web. It literally means the process of showing layout and content of a web page in the screen by the browser. So before a couple of years, languages like PHP and Java were responsible of delivering ready web pages to the browsers. And this is where server-side rendering techniques were used back then at that time. That was all before the rising of JavaScript and its frameworks. Now, when JavaScript had come to take place in the web, frameworks like React and Angular changed the way of how the web works, and it made almost everything handled by the client side in JavaScript. Moving to the next slide. Okay, client-side rendering. First of all, let me explain how does client-side rendering works. In other words, here is what happens when you visit a web page written in React or any client-side JavaScript framework. As you can see, first you request the HTML and CSS files from the server of that website. And second, then the browser renders those HTML and CSS, it renders those files to the screen. After that, the browser downloads all the JavaScript and static files from the server. And in step 4, the downloaded JavaScript file get parsed and compiled in the browser. As you can see, we still have an empty screen here. Nothing is painted. Nothing is painted yet to the browser, to the user. Now, after that, in step 5, you can notice that a loading bar is shown up because all our JavaScript is compiled at that time. And in the meanwhile, your code starts to fetch the data from the server. After all these steps are finished, all these steps actually runs in sequence order. And after all of them is finished, you will be able to see an interactive web page ready to be seen and clicked. Okay, now let's see. Sorry, yeah. Let's see how server-side rendering works when you click to visit some web page that is server-side rendered. As you can see, first you request the static HTML and CSS files, just as like client-side rendering. But the difference here is that the server sends also the data included in the HTML file. After that, the browser renders that meaningful HTML to the screen, and as you can see here, the user will see a web page with the layout and content, but he might won't be able to interact with the page because of the JavaScript might not be compiled yet at that time. After that, the browser, in step 3, the browser downloads all the JavaScript and static files from the server. And in step 4, it parses and compiles the downloaded JavaScript. At that time, when all these steps are done, you will notice that a web page now is interactive and clickable. But remember that the page has been viewable by the user since the end of step 2 from here. So it's pretty obvious that the content will be seen with server-side rendering in much earlier time than the client-side rendering would take. Okay, now let's talk about the pros and cons of both server-side and client-side rendering. Starting with the server side. The pros are server-side rendering works better with SEOs because Google search engines can have the whole HTML page with its meaningful content and data. Second, the initial page load time is much faster in server-side rendering. Third, great for static websites in general, especially for articles or websites that has a huge content and text. Now, let's go to the cons. First, frequent server requests on every page refresh of the website. Second, full page reloads and less of caching control. So the biggest cons of server-side rendering is that it loads everything in each page refresh. Okay, now let's talk about the pros and cons of client-side rendering. The pros are, first, it has rich website interactions. It is it has fast page rendering after the initial page load. Third, it's great for web applications. And fourth, it has robust selections of JavaScript libraries that support it. Now let's talk about the cons of client-side rendering. First, it has low or kind of bad SEO control for the website. Because the search engine will have an empty HTML page while the JavaScript is being loaded and compiled. Because in client-side, JavaScript controls the page. Second, the initial page load requires much more time than the server-side rendering would take. Okay, now why do you think about server-side rendering? Okay, since we have modern client-side libraries like React and Vue, Angular, etc., why do you think about server-side rendering now? Actually, the main reason for rethinking about server-side rendering is the bad user experience that we could have in a bad network connection when using client-side rendering approach, especially on mobile devices. Client-side rendering would make the page depends totally on the JavaScript, as we said before. Makes it very hard to achieve good performance levels for users with bad internet connections. While the page is still loading the JavaScript bundles and the data, a user with bad internet will end up waiting seconds, looking at a white screen, and this would be really frustrated if the page was an article or a payment page. Okay, now good news. The good news is that we can have the best of both worlds by using both server-side rendering for the initial page load request and client-side rendering for other routes requests in the same website. And we can achieve that easily by using JavaScript libraries like Next.js, which uses the same code base of React.js in the client side, where it also provides a small API for configuring the initial server-side rendered components in Node.js. So you can consider Next.js is literally React.js with the support of server-side rendering. Now, to prove my point, let me show you a performance comparison for two websites. One of them is client-side rendered written in React.js, and the other side is server-side rendered written in Next.js. Okay. I suppose you can see the websites for now. As you can see here, this is the first website, is server-side rendering using Next.js. It only shows the Rick and Morty characters. Sorry. So when I click refresh, it's normal. Also, this website is client-side rendered using React.js. It's working normally. But let's test those websites in a slow network, in a slow 3G network. I'm going to use DevTools for this. Now, I have the server-side rendered app. I have opened DevTools before here. I will choose network slow 3G. And I'm going to just start profiling and reload the page. Great. So let's look what is going on here. First, the website downloads the HTML and the CSS. It takes up to 2 seconds, as you can see here. And immediately after that, it starts to render the web page with the meaningful data. As you can see, the characters' names here are being shown up. And in the meanwhile, the JavaScript will be downloaded in the network asynchronously. So at that time, the user can really interact and see everything in the page. So we can consider the page is ready and interactive at 2 seconds and a half. Now let's see how things work in client-side rendering website, which is written in React. I have chosen also slow 3G, the same. I'm just gonna click reload, start profiling and reload. Now, as you can see, guys, here, the HTML and CSS takes up to 2 seconds to download. We still have an empty page. There's nothing here to be shown. And after that, the JavaScript is being downloaded, and it has really big time to download here. It took like 3 seconds. And after the JavaScript is being downloaded, we have the screen printed out, but there's no data yet because it needs to fetch the data from the server. So as you can see here also, it took up to 2 seconds, 2.2 seconds to download the data from the server. And you can see that we have the data printed out at second 8. Now let's compare to the server-side rendering. We have here the second 8, the data, and we've got the data here like at the second 2.5. So as you can notice, there is big difference in performance between the two of them, especially when you choose network as a slow 3G or slow 4G even. And that was all from me. I can have questions if you have any, guys. If there is no, I'm gonna give the mic to my friend John.
Okay. Hello. I think my presentation is going to be much shorter compared to those, but let me share my screen. Is it properly seen? Not yet. Okay. How about now? Okay. So, what is a context switch? It is actually a low-level concept related to operating systems, which most of you probably have learned in college. So it's a process of suspending and resuming processes, which means that that there's a way that the operating system handles all those processes that are running. And since multitasking has become available sometime in mid-90s in widely used commercial systems, this is the usual way of handling a process switch. So it's basically triggered by 3 different types. The first one is interrupts. It's, for instance, an I/O interrupt, which might be a disk or network or anything that includes actually a response from another system. So you might actually compare this with asynchronous programming in some of the modern languages. So whenever there's a process that needs an I/O input from some third-party part, then it doesn't wait. It just switches the task to a different process, which can continue. The other one is preemptive multitasking. Some of you might know it as time slicing, which is, the operating system, if you don't actually mess with it, it handles these processes according to a priority list. So whenever a time is up for some process, it might switch to another process because it has higher priority. But of course, we are considering a single core CPU here, handling a multi-process operating system. So in multi-core systems, this might be done without time slicing, or it might be simulated in some single-core computing devices by using hyper-threading, which is also quite old technology. Or it can be done, it can be triggered when there's a user kernel mode switching in the operating system, which is, again, not in every operating system needs this, but because it's a part of a context switch trigger, I included it. Some operating systems does this when it is switched between user and kernel, but some of them don't. So what the process context is actually where we store the process information, and it is represented by a process control block, where we store every variable that we need to actually resume a process. So this sequence diagram is actually more clear from my point of view for two processes, process 0 and process 1. And once process start is executing and there's an interrupt or a system call, then the process P1 has to be has to go on, and process 0 has to stop. For that, as you can see in the diagram, we first save the state of process 0 into PCB 0, and then we reload the state of PCB 1 from wherever it was stored in the PCB. And during this time, the P1 is idle. And while saving it, it's still idle. So both of them are idle while doing the saving and reloading, which is a waste of time, of course. And then the process 1 executes for some time. And then we try to switch back to the P0, which is the same thing repeated again, which means that all those times switching and saving and reloading is wasted because they're idle. So this is a good visualization of the cost of context switching in modern hardware. So if you're multitasking, there's definitely an overhead, and this overhead is represented with the black boxes in the second part. So if you do those things sequentially, it takes much less time to actually achieve it. So this is from the hardware point of view, hardware and software point of view, because older architecture used to do this process switching with hardware, but newer hardware and software does this with software. So basically, it's the operating system handling this right now. What I want to point out is actually, maybe I digress a bit, but still, what I want to point out is the context switching cost in humans. We've already seen that the machines have a hard time adapting to lots of context switching, which comes with an overhead. But in humans, this is much worse. So a human is basically capable of just doing a single task if it's focused on it perfectly. And if you push it hard, if you think of each of our brain hemispheres as one processor, which is a quite generalization and it's quite far from the truth, but still, we can somehow make do with two tasks being done at once. But if you introduce a third task, then one of the first two tasks gets replaced, which means that judging this from an operating system point of view, if you introduce a third process in the first slide that I've shown you, then the first one is lost, which is quite stupid. You might think of it like when you alt-tab twice, the first process is just killed. So this is the structure as current neuroscience thinks about humans, which makes multitasking and context switching much more costful in humans. So my basic point in this whole presentation is, if you're interrupted with a lot of things during the day, and if you're dedicating a lot of time responding to different environments, that means that you are working suboptimally. And what you need to do instead is somehow organize and plan this and make it in chunks, in sequential chunks. That's all. Thank you.
Hi everyone, can you hear me? I'm sharing my screen. Can you see my screen? Okay, let's start. I hope everybody is doing well. My name is Ferhat, and I am working as a software engineer at iyzico. Now I'm talking about the advantages of Kotlin, as you can see in my screen. I try to explain some basic concepts and some of usage. I try to keep it short as soon as possible. Okay, let's start. At first, let's look at the agenda. I'm going to tell 6 main topics about Kotlin. The first topic is a question. What's Kotlin? I'm going to talk about that. When did it start? What kind of programming language? Who is behind? And some benefits. The second one is about declaration. How can define a variable, or how can create a method? The next one is about classes. And then I'm going to tell about null safety. Null safety is one of the important concepts in Kotlin. And finally, I'm going to tell extension functions and Lambda expressions. What's Kotlin? Kotlin is a statically typed programming language. So what is statically typed language? It's associated with variables, not with values. As you know already from Java, in statically typed language, variable types are explicitly declared, and therefore it's determined at compile time, which means you can not add fields and methods during runtime. Kotlin was developed by JetBrains. You know JetBrains from IntelliJ. It was started to develop in 2010, and after 2 years, in 2012, it became open source. Google announced support for Kotlin in its Android Studio. Now, more than 50% of professional Android developers are using Kotlin to develop their apps. Also, it combines object-oriented and functional programming features. It means you can use both object-oriented and functional programming styles. And fully interoperable with Java, which means you can easily call Kotlin code from Java and Java code from Kotlin. Now I'm talking about declaration in Kotlin. As you can see in my screen, functions are declared with fun keyword. You have to write method name and variables after fun keyword. Finally, you should specify return type if you need it. By the way, the picture quality is not good. Sorry for that. If you want to define a variable or class property, you have 2 options, val and var. Val is equivalent to final keyword, as you know from Java, and var is a mutable declaration. You can see example on the right side. If you want to specify the variable type, you should indicate like this. Next topic is about null safety. Kotlin helps us to avoid null pointer exception. I think, like everyone, it's not acceptable situation in production environment. So how can I use this? We can declare a variable. It can be null or not. Let's look at the example. A variable cannot be null and B is nullable. And then when we call the test method like this or like this, code won't compile. But we call the test method with these parameters, code will compile. So what am I doing when I call an object property? Kotlin has a tree operator for this situation to avoid null pointer. The first one is save call operator. If you want to get name property value of a teacher object, we can call like that. The second one is else operator. We can think this operator like or else. If last property value is null, we can assign default value to variable. The last one is not null assertion operator. If we are sure that variable absolutely not null, we can use this operator and then code will compile successfully. But I think you should avoid to use this operator. Next topic is classes. Classes in Kotlin are declared with class keyword like any other language. Also, if you want to inherit a class, you can do basically like this, but it won't compile because by default, Kotlin classes are final and they can't be inherited. If you want to inherit a class, you have to specify with open keyword. There's an example on the screen. And there's an example about interface. Let's continue with the classes. Sometimes you create a class, only hold data without additional functionality. There's an example from Java on the screen. I create the class with getter setter to string hashcode echoes methods. We can create this class very fast, simple, and more readable in Kotlin like this. To string hashcode and echoes method is default feature in Kotlin classes. Next topic is extension function. This is my favorite one. Kotlin allows us to extend the functionality of existing class without inheriting. The only thing you need to do, create new function and add class name before method name, like at the example, and then you can use it on a class as a property method. I want to tell another feature for the functions in Kotlin. If you marked any function with infix keyword, you can call like at the example. This is more readable. I think it's very cool. This is the last topic, Lambda expressions. I compare with Java in Lambda expression. At first, I want to show you a Java stream example. I created a string array list with hero names and started Java stream. And then I filtered some of them according to some rules and concatenated with movie string. Let's look at the same code in Kotlin. We can do the same thing, less code and readable in Kotlin, and besides, we don't have to use a collect method. There's a lot of useful concept in Kotlin, but that's all I can tell for now. Thank you for listening and have a great day.
Thank you, Ferhat. and thank you to all the speakers for their presentation today, and to all the others for their participation. I think we are going to schedule our next talk, Lightning Talks event, in 5 or 6 weeks' time. So if you want to make a presentation in the next one, you can get in touch with me. Have a nice weekend all. Bye.